So good day everyone. So today we're gonna talk about the measures of central tendency. So measure of central tendencies provides a very convenient way of describing a set of scores with a single number that describe the performance of the group or a certain group. So it is also defined as a single value that is used to describe the center of the data. So there are three commonly used measures of central tendency. These are the following, which is mean, median, and mode. There.
Wow.
Mode. So there are two types of data that we're going to be tackled this afternoon or this morning on your behalf, or evening, or whether what time is it that you're watching this video. So
Wow.
there are two types, the ungrouped data and the group data. So before that we must
What?
define what is the ungrouped data and the data or the group data. So ungrouped data is the data that you first gather from the experiment or study. That data is raw, that is not sorted into a categories, classified or otherwise as a group data. So an ungrouped set of data is basically a list of numbers. So while the group data is the scores that are arranged in a frequency distribution. So what is frequency distribution? Frequency distribution is the arrangement of scores according to a category of classes, including the frequency. You get it?
Gotcha.
Okay. So frequency is the number of observation falling into a category. So now that we already know what is the group and the ungrouped data, we will proceed now to the what is mean, or what the definition of mean, and how you will get the mean when you have the data ungroup or the group data. So we'll proceed, and yes, I really don't know. So mean is defined as the most commonly used measure of the center of data. It's also called, or it's also referred as the arithmetic average. So in ungrouped data, the mean is computed by adding all the numbers and in the data together and divided by the number of elements contained in the data set. So this is how you get the mean in the ungrouped data.
So for ungrouped data, let's talk about the definition of terms. So sum of x is equals to sum of all numbers in the data set, while the n is the number of elements in the data set. So the formula used, or that we're going to use for the ungrouped data, is x is equals to sum of x over n. So for example, we have the data set here of 1, 3, 4, 4, 5, 8, and 10. So by getting the mean of this data set, we have to add all these numbers and divide it by the number of elements of this data set. So let's start. So x is equals to 1 plus 3 plus 4 plus 4 plus 5 plus 8 and plus 10 over, so that will be 1, 2, 3, 4, 5, 6, 7. So this data set has a 7 element. So for the people who cannot solve this by their head, you have to need a calculator. But for me, I don't need calculator because I'm somehow genius enough, and yeah, I can do it without the calculator. So first, we have to add the data set, which is 1 plus 3 plus 4 plus 4 plus 5 plus 8 and plus 10. So x is equals to, that will be 35 over 7. So x is equals to 35 over 7, or divided by 7. The answer will be 5. So the mean of this data set is 5. So that is how you get the mean of the ungrouped data.
So guys, I'm just messing around for not using a calculator.
What?
I need to use this calculator. So anyway, we will proceed to median. So a while ago we talked about on how to get the mean in a gun group data. So now we will talk about what is median. So median is what divides the scores in the distribution into two equal parts. So 50% lies below the median value and 50% lies above the median value. It is also known as the middle scores of the 50th percentile. So this is how you get, or this is the process on getting the median measurement in a ungrouped data. So let's find out.
So median of ungrouped data is arrange the scores from lowest to highest or highest to lowest. So for example, we're just gonna use the first data set that we use in the mean by getting the mean. So we just have to arrange it from highest to lowest or lowest to highest. So for this case, we're gonna arrange it from highest to lowest. So that will be 10, 8, 5, 4, 4, 3, and 8. So median, by getting median in the ungrouped data, the second thing you must do is determine the middlemost score in a distribution of n if it is an odd number. So if the number of elements is odd number, you just need to search you just need to find the middle number. So for example, this is 1, 2, 3, 4, 5, 6, 7. So basically, we have 7 elements. So because it is a odd number, it's easy to find what is median in this data set. So the median of this data set, wrong spelling is wrong. Okay, so the median of this set is number 4. So that is the process, or that is how you get the median of a data set for the ungrouped data. So let's go to the even numbers. So for example, we have a data set of 10, 8, 8, 5, 4, 4, 3, 1. So the number of elements of this data set is 1, 2, 3, 4, 5, 6, 7, 8. So by getting the median of this kind of the data set, which is the number of elements even number, you have to add the two middlemost scores in the data set, so which is 5 and 4. So the formula that you're going to use is not something, but just you just need to add the both. So 5. So x is equals to 5 plus 4 divided by 2. So that will be 5 plus 4 is equals to 9. That will is equals to 9 over 2 divided by 2 divided by 2. That will be 4.5. So the answer of this data set is 4.5 for the median of this kind of set. So that is how you get the median of the ungrouped data, whether it has the odd number or the even number. So now that we already know how to determine the mean median mode of in-group data, let's now proceed on how to determine the mean median mode of a group data. So for example, we have a data set of group data of this class interval, which is 55 to 64, 45 to 54, 35 to 44, and 25 to 34, and 15 to 24. So the class interval in the frequency is already given. So in order for us, in order for us to get the mean median in mode, we have to first we have to add another column here, which is the midpoint. So by getting the midpoint, so m is equals to lower boundary plus upper boundary divided by 2. For this case, so we just need to add the lower boundary, which is 55, and the upper boundary in 64, and divide it by 2, so we can get the midpoint. So get the calculator. So 55 plus 64 is equals to 119 divided by 2. That will be 59.5. So next, 45 plus 54 equals to 99 divided by 2. That will be 49.5. As you can see, we have already a sequence here in our midpoint because we have the same class interval. So let's assume, or we can now assume, that the next midpoint of the 35 and 44 will be 39.5, 29.5, and 19.5. So now that we already have the midpoint, we need again to add another column here. So for now, we will search the sum of the frequency, or number of the frequency, times the midpoint. So 3 number of frequency times 59.5, that will be 178.5. 8 times 49.5, that will be 396. 7 times 39.5, that will be 276.5. 6 times 29, 6 times 29.5, that will be 177. And last, 2 times 19.5, that will be 39. So that's not the end of our table. So next we have to add another column, which is the CF, or the cumulative frequency. So in order for you to get the cumulative frequency, first we just need to rewrite the first frequency here. So that will be number 3. So in second, so we can get this, you just have to add number 8 from the first CF, or cumulative frequency. So 3 plus 8, that will be 11. 11 plus 7, that will be 18. 18 plus 6, that will be 24. And 24 plus 2, that will be 26. And then after that, you have to sum all of this. You have to sum all the frequency and the number of frequency times the midpoint. So this will be 26, and this will be 1067. So you just have to add all of this to get this one. So as you can see, the final number that here in the cumulative frequency is the same at the total sum of the frequency. So now that our table is already complete, we'll now proceed on getting or determining the mean. So by getting the mean, we have a formula. So M is equals to number of frequency times midpoint over N, or the total number of frequency. So that will be, so M is equals to 1067 over 26. So 1067 over 26. That will be 41.038 or 41.04. So this is already, or we already know what is the mean of this data set. So next, so as you can see, the mean is 4104, and let's go back to the table. The 41.04 lies in this group or class interval. So in order for us to get the midpoint, or to get the median, we need to get first the mean of this data set. So the 41.04 is somewhere between 35 and 44. We have to box this in order for us to get the median easily. So box this one. So now that we already boxed it, we will proceed on how we will get the median. So median, we have also a formula on getting the median, that is M is equals to L plus 1/2 times total number of the frequency minus CF over FM. So in order for us to get the L, we have to get the lower boundary. So lower boundary is 35. Just subtract 0.5. So that will be 34.5. So next, n, or the total sum of the frequency, is equals to 26. CF, or outside or above the frequency, or above the box, which is frequency above the box, is 11, and FM is inside the box, which is 7, and the class interval, which is 10. How did I get 10? Because it's 55, 56, 57, 58, 59, 60, 61, 62, 63, and 64. So that's how you get the class interval. So now let's proceed and substitute everything. So L is 34.05 plus 1/2 times 26 subtracted to 11 over 7 times 10. So first we have to solve first what's inside the parentheses. So 1/2 times 26, that will be 13. So copy 34.05 plus open 13 minus 11 close over 7 10. So 13 minus or subtracted to 11, that will be 2. So again copy 34.05 plus 2 over 7 close parenthesis 10. So 2 over 7, that will be 2 over 7 multiplied by 10, that will be 2 point, so copy first 34.05 plus 2.857 or 2.86. So now add the 34.05 and 2.86. So 34.05 plus 2.86, that will be 36 point or 34.5 times or add plus 34.5 plus 2.86, that will be 37. That is not 0.5, that is correction, this is 34.5. okay, sorry for the mistake. So 34.5 plus 2.86, that will be 37.36. so that is already the median. So by getting the mean, we can now determine where in the data or the data set can be found the median. So that is 37.36. It's between 35 and 44. So next, let's proceed to mode. So by getting the mode, we need first we need to determine what is the highest frequency, and the modal class of it. So in the data set, the highest frequency is wait. In the data set, the highest frequency is 8, this one. So we have 8. So the modal class of this is 45 to 54. So modal class is 45 to 54. So now proceed on the mode itself. So mode is equals to lower boundaries MO plus D1 or over D1 plus D2 times interval or the class interval. So lower boundary, which is a number 45. So lower boundary 45 minus 0.5, that will be 44.5. So in order for you to get the D1, you just have to subtract the frequency or the highest frequency to its what is the above number frequency, that will be the D1. And for D2, what is under the highest frequency. So that will be D1 is equals to 8 minus 3, that will be 5. And D2 is 8 minus 7, that will be 1. And the interval is at east, that is number 10. So now let's proceed on getting the mode using the formula and substitute everything. So mode is, let's here, mode, that is equals to LBMO plus D1 over D1 over D plus D2 times interval. So 44.5 plus, what is D1? D1 is 5 over 5 plus 1 times 10. So first we have to solve what's inside the parenthesis. So that will be 44.5 plus 5 over 6 times 10. So that will be 44.5 plus, so you need the calculator, so 5 over 6 times 10. That will be 8.333 or 8.34. So 44.5 plus 8.34. So that will be, that will be 52.84. So this is already our mode. So that's how you get the mean, median mode of a group data. So thank you for watching. I hope you understand, and for some question or clarification, just notify me and just click the bell button and subscribe and the like button. So thank you and have a nice day.